So we are going to be talking about separable equations today. Can you see this? Can everybody see what is on my screen?
It's supposed to be like blue and yellow.
Yes. If you don't like those colors, I can change and put others. You like this one better?
Yes.
It looks like a blackboard, right? So, okay, so we are fine with this blackboard, so let's go with it. Now, what do we call a separable equation? What we call a separable equation is an equation of the kind, or an equation that we can write in the form f of x dx equals g of y dy. So if you have a differential equation that you can write in this form, then you call that equation a separable equation. And if the equation turns out to be separable, how do we solve it? So this is what you call separable equation. And how to solve? So usually step 0 in solving this kind of problems, in the case when the problem is not given to you in this form, the first step is to separate the variables. Separate the variables to obtain f of x dx equals g of y dy. So that's the first step when you have the feeling that the equation that you have in front of you is a separable equation. So you separate the variable to obtain the equation of this form. And then you do step 1, integrate both sides of the equations. Integrate both sides of the equation. To add a constant of integration. C to one side. It doesn't matter which one. Add a constant of integration to one side. And believe me, I always do like this. I list all the steps that you need to do to get the problem solved. And then I get the example. We go through following those steps. And I always ask you, please follow these steps. It makes your life easier. In your book, they don't bullet point it like that. But in a lecture, I do that. And I hope that it helps when you follow them. So, and then in the last step, so if you have initial values, and this is what most of the time students forget. If you have initial values, use them to find the value of the constant of integration. C being the C that you added to that side. So that's it. These are the 0, 1, 2, 3 things that you need to do when you have a separable equation. Now, the most difficult thing in all this is actually this step, because when I say integrate both sides, easy said, right? But the thing is, do you remember how to do integration from Calc 2? Or if you don't remember, then that's where your problem will start. So you need to start by remembering some of the things that you did in integration, like U substitution, integration by parts, and things like that, right? Remember that. So we use a lot of things from your calculus courses. So do we have any question for the steps that we have here? Now, one quick example to apply. Example 1. In this example, let's say we have dy over dx equals e to the 3x plus 2y. So you have a problem like this. So technically you can see that this problem is not written in the form f of x dx equals g of y dy. So you need to bring it to that form if this problem is separable. And the reason why we can do that is that here, this e to the 3x plus 2x, it's e to the 3x times e to the 2x. So we can actually write that right-hand side as a product of two functions, one of which has to do only with x and the other one has to do only with y. So we separate those functions, and now we can send all the x's to one side and all the y's to another side, and therefore we will complete this step. Am I making sense? All right, so here, if the question is solved, and then let me even add something here, y of 0 equals 2. And so in that step 0 answer, you would start by saying dy over dx equals, this is e to the 3x times e to the 2x. And here we are using the properties of exponentials. E to the a plus b is nothing but e to the a times e to the b. That's a property of exponentials.
That should be e to the 2y down there.
Yes, thank you. All right, so e to the a plus b is e to the a times e to the b. That's what I'm using here. And then from here, I can separate these things. E to the y can go to the left-hand side, or I can send e to the x to the left, no matter what you want. You can do anything you want. So that's be dy over e to the 2y equals, and dx goes to the right. So that's e to the 3x dx. Now you can see that you have all the x's on one side and all the y's on the other side. That's what you call separating the variables. So each of the variables must be on its side alone, without the other one. So at this point, we say, yes, we have separated the variables, so we have completed that step 0. And then you go to the next step, which will be integrate both sides. Integrate both sides of this equation. So here that will be integrate. And here that was separate. So we have separated the variables. Now we integrate. So that will be integral of dy over e to the 2y equals integral of e to the 3x dx. So this gives me integral of e to the negative 2y. Whenever you have exponentials, you bring them to the top. E to 1 over e to the 2y becomes e to negative 2y dy equals, and integral of e to the 3x is 1/3 e to the 3x, right? And we said put a constant on one side, so I put c on this side. That's the part, add the constant to one side, right? And now I can integrate this one as well. So that gives me negative 1/2 e to minus 2y equals 1/3 e to the 3x plus c. Now you have solved that. And then you can go to the last step, which said, if you have initial values, use them to find the value of C. Do I have initial values in this problem?
Yes.
Yes, it says y of 0 equal 2, right? So you got to use that. So you're going to use that fact here. Initial values. So initial values, we're going to use them. So y of 0 equal 2. So that's what it says. Y of 0 equals 2, which means plug in 0 for x, plug in 2 for y, and get C. So y is 2. So that's minus 1/2 e to the minus 4, because y is 2, equals 1/3 e to the 0, because x is 0, plus C. So that gives you C equals negative 1/2 e to the minus 4. And then you send this to the other side. E to the 0 is that's 1. So it comes here, it becomes minus 1/3. So that's the value of C. And now with that value of C, you can go back and write down the final answer. That is minus 1/2 e to the 2y equal 1/3 e to the 3x plus C, and C is minus 1/2 e to the minus 4 minus 1/3. And then that's it. Questions? Do we have any questions, please?
That's supposed to be negative 2y on that first e, right?
Can you say that again?
That's supposed to be negative 2y on that first e, right?
Here?
Like
No. Yeah, that's negative 2y.
Okay.
I just copy, thank you. I just copy the answer you have here to replace C by its value, right? Other questions? So this is technically what this thing is about. So and it's never going to be something else. Never going to be more difficult than seeing that, separating the variables and integrating, right? So let me show you another example. So example 2, let's say we have x squared y squared dx, dy, x squared y squared dy equals y plus 1 dx. So you have a problem like this, and you can see when you look at this problem that the variables are not yet separated, right? But this equation is also separable. Why? Because through simple correct manipulations, we can get the x's on one side and the y's on the other side. That's why it is a separable equation. So if we divide both sides by y plus 1, we're not going to have any y anymore here. If we divide both sides by x squared, we're not going to have any x anymore on the left. So that's why it's separable. So now we're going to do that step 0, divide by what I just said. So, and that's step 0, which is separate the variables. How do you do that? Here in this case, you divide, in this case, by x squared times y plus 1. Both sides, right? And when I do that, here I get y squared dy over y plus 1 equals, when I divide here, I get dx over x squared. Now you can see that you have all the y's on one side and you have all the x's on the other side. Does this make sense? Some people are so calm that I don't know if they are here or not. Is Michael Reed here with us? Okay. All right, so we have separated the variables, and now we're going to do the next step, which is integrate. So we integrate both sides. So you get integral of y squared dy over y plus 1 equals integral of dx over x squared. Now, this thing on the right here is easy to integrate. That's just minus 1 over x. And then I say put that constant of integration there. But the integral on the left, you gotta do a little bit of work on it, right? Do you see that? Y squared over y plus 1. You gotta do what you call the partial fractions. And if you don't want to do that, you might consider first doing u substitution. So here for this one, I'm going to do u equals y plus 1, do u substitution. Du is therefore dy. So that integral is integral of y squared. Y is u minus 1, so that's u minus 1 squared. Y plus 1 is u, and dy is du equals minus 1 over x plus c. So you keep this in mind. That's the substitution that we did. And now after doing that substitution, we open the brackets here, cross multiply. So that's u squared minus 2u plus 1 over u du. There are so many u's in it that I don't know if you are following. That was my first joke.
I laughed. I was just on mute.
What was that?
I said I laughed. My mic was just muted.
Okay. Sorry. All right. So again, so here now, what we need to do is split this thing, guys. So u squared over u, and u squared over u. That's u, right? Well, we should have choose a different letter. So minus 2u over u. So that's minus 2, and then plus 1 over u. And then du, negative 1 over x plus c. Great. And now we integrate this. Integral of u is 1/2 u squared minus 2u. And the integral of 1 over u is natural log of absolute value of u equals negative 1 over x plus c. And now here we return the substitution. So we return the substitution that we had here. U is y plus 1, so that's 1/2 y plus 1 squared minus 2 times y plus 1 plus natural log absolute value of y plus 1 equals minus 1 over x plus c. That's it. Final answer, man. And I think that's on time. 13:45. Did you see that? That's the best timing, right? So you have any questions, you feel free to ask them. You don't have any questions, you can run to your next lecture. Anyway, that would be running from your room to your room, from one class to another, right? There's something good about this anyway. So it's not all negative. We work less now. We go out less.
I've found that the pandemic has turned me into a bit of an agoraphobic shut-in.
Yeah, I'm telling you.
I was already antisocial before the pandemic. This has not really helped.
You see, really. There are many bad and good things, but you know, but it's not all that, all negative. I'm that kind of person that always tries to find something positive when everything is weird. You know, you just accept that it's all weird and there's no reason for living. Yeah. Okay, do we have any questions for me at this point?
Could you scroll up to the top of this problem that we've just been working on? Okay, thank you.
All right. We good? Next one. Shall we go to the next? Okay, and the next obviously is something that you guys do and I just sit and look at you do it. Otherwise, if the whole course is just me solving, then we might end up saying, hey man, this was just a one-man show. So I'm going to ask you to do another one now. Exercise dy over dx equals 1 plus 2y squared over y sine of x. And I'm giving you 5 minutes to think and work through it. So usually what I do is that if somebody has an answer, I can get him to connect his screen so that he can show what he's doing. If he can't do that, then I'll present it myself. This is the problem we are solving. So please connect and try to solve that now. It always helps. So, any good news? Anyone with an answer to this problem?
I have an answer, but I can't promise that it looks pretty.
Well, the most important thing is what you have done. So, pretty or not, it's not important. What are the steps? Did you follow the steps? If yes, then okay, let's see. If you have the possibility to share your screen, that would be great.
All right, let me just see if I can. All right. How do you share a screen? Okay, there we go. It said host has disabled participant screen sharing.
Yeah, I'm looking at you to see who is doing.
Oh.
I need to give you the permission to share.
Oh, okay.
That's John Russell, right?
Yes.
Okay.
I also just want to say I put my full name on here for attendance, but I go by Cooper.
Cooper? Okay, no problem. You actually don't need to put a name if they attend for the attendance, because if I just see your preferred name, it will be fine.
Oh, thank you.
Okay, I'm making you co-host.
Let
kind of disturbing.
What's disturbing?
Now it's fine. You have the right to share your screen.
There we go. All right. Well, I didn't. I'm sorry. I don't have it on my screen. I have it on a sheet of paper, but like.
And show it. That's what I call my.
Oh, okay.
So
I see. I'm sorry. I was just misunderstood. Okay, there we go. Okay, so here's what I did. So we have dy over dx equals, I'm going to rewrite that x.
Mhm.
There we go. Equals 1 plus 2y squared
over y sine x.
over y, all right, over y sine x. Very nice.
Mhm.
So first thing I did, I got all of the y's and all of the x's together. So on the left, I had dy,
Mhm.
that's y over 1 plus 2y squared. That's terrible.
That's
Draw there.
also
Draw
always
there.
issues with
Sorry,
that too, so
Yeah, sorry, my cursor is having just a little bit of trouble. So 1 plus
2y squared.
2y squared.
All right, that's correct.
And on the other side, I had dx cosecant of x.
Mm-hmm.
Now, I don't know if this is allowed. I don't remember how to prove it, but I just have memorized that the antiderivative of cosecant is the negative natural log of cosecant plus cotangent.
Yeah, that's fine. You can use it.
Okay, sweet. So on the left, let me move my,
Substitution.
yes, I used u substitution with u equals 1 plus 2y squared.
Correct. That's the right thing to do. So
Equals. I'm sorry, I can't write this fast with my trackpad.
it's fine. So I'm hoping that as you are doing, others are getting it. So
Thank you. So du equals 4y dy.
correct.
So I got that 1/4. I'm just going to skip a step here. 1/4 du.
Mm-hmm. It's y dy.
Yes.
That's correct. So why you said it's not beautiful? This is the
Well,
best.
mainly my handwriting. My handwriting is the ugly part of all of this, but
Okay, because it is nice and short, and that's exactly what I would have done if I was to show you that. So
I appreciate that. So the next thing, I would just plug this in
integrate
up
both
here.
sides.
Yes. So I have 1/4 times the integral of du over u. Making sure I don't lose track of myself here. Equals the integral.
Hopefully everybody understands what you're doing here. Is you're doing u substitution inside the integral. So I better put the signs of integral so they understand it. So you're integrating both sides of your equation.
Yes.
And do u substitution for the left, right?
Yes, I'm doing u substitution for the left right over here. I don't know if y'all heard my computer. My computer just tells me it's 2 o'clock or whenever the hour strikes it. So don't worry about that.
All right. And then the right-hand side gives you natural log.
Oh, I could just skip that step. Yeah, I already mentioned the antiderivative. Let me find the eraser. So the natural log, or sorry, the antiderivative of this on the right would just be negative natural log of the absolute value of cosecant plus cotangent. That's a mouthful. cosecant x.
When it comes back to me, I'll just show you the trick on how to show that. Yeah.
Oh, thank you. On how to prove the antiderivative,
Yeah.
you mean?
Yeah.
Okay, thank you. So that's that. And then on the left, well, we can just pull the 4 over here, leaving us integral of 1 over u on the left. This gives us not negative, just natural log. Sorry.
Absolute value of u. Yep.
Actually, I should put a plus c over here. That's my bad.
I was still waiting because you still
That's my bad. Yeah.
You still have one integral on the left, so you were still correct until you finish that integral and you don't put the constant. That's where the problem will be.
There we go. I'll just save that then.
Yeah, so if you don't put it there, it's not a problem. Till you finish computing the other integral, you're still fine.
Very nice. Okay. So we have -4 times a natural log of this mess. If I can write it clearly. Cotangent x. There we go. And then I'm going to go ahead. I haven't plugged my u back in, but I'm going to go ahead and put the plus c right here. There we go. And this leaves us with natural log of 1 plus 2y squared. This is this is getting progressively worse to read. I'm sorry.
I can read clearly. I don't know what about others. Is everybody fine?
I'm going to rewrite this y just so that's not quite as bad. Perfect. So natural log of the absolute value of 1 plus 2y squared equals -4 times the natural log of the absolute value of cosecant of x plus cotangent of x plus c.
Correct. That's it. And now you can continue there to remove the absolute values, but to remove the natural logs, but we can just stop at that. It's not necessary to continue to remove.
Thank you so much.
All right. So thank you for doing the work. So that's it. So plus c.
Plus c. Well, my cursor went away. Crap. There. I'm just writing this for completion's sake.
Yeah.
There we go.
That's it.
Finished.
Great. So that's it.
Thank you for coming to my TED Talk.
So that's the equation. That's how you do separable equations. And I hope that we all followed and that it flows and that everybody understood that. Is there any other questions on this topic? You want to do one more example?
I have a question. So from the problem you gave us, can you work from there to like the y's on the left and the x's on the right, like with the cosecant? Can you work to that step?
Okay, I don't get what step. Do you have the possibility to show what you still have there?
I'm not really. I don't have the thing that he has, so
I'll see if I can pull it. Okay, no, I'm sorry. My whiteboard went away, but I have it on my paper right here.
like step zero. Step zero.
Okay.
Yeah, can you just finish step 0 and then I'll be fine.
Yeah,
like work it out.
Back to me. Okay, it's fine. I'm taking over.
Oh, Dr. Longlow, are you gonna show the thing?
Yeah. And so this is the part he's asking about on separating. So you have dy here on top. You have y here below. So this y can go up here. This 1 plus y squared, it's at top. It goes to the bottom. So you are going to have y dy over 1 plus 2y squared, because this y from the bottom went to the top and the 1 plus 2y squared from the top went to the bottom. And then that's equal, the over dx goes to the top. So that is dx. and the over sine x remains where it was. Are we good? Is that what you were asking?
Where did cosecant come from then?
1 over sine x is cosecant.
Oh, okay. That's what you're saying. Okay, I got it.
Mm-hmm. Anything else? Are we good with the rest of what he showed? Okay. Thank you very much again, Cooper. So let me have another problem. Let me write another problem here and try to see if we solve it. So we have dy over dx equals y squared minus 1 over x squared minus 1. Again, I can't emphasize this enough. Please, guys, when I give a problem like this, try solving with us. Try solving with us. Even if it doesn't work, ask. Because this is when we learn. When you get home on your own, you are alone. That's the time to practice, not to be learning the definitions, because at that time, there's nobody you can ask to. And you go now look for maybe a tutor that will mess you up again. So in class, when we have activities, please do with us. You have questions, ask them, and I will answer. And then in this problem, it says y of 2 equals 2. So the initial values are given. And again, the first step is you separate the variables, and then you integrate in the second step. So we have like 5 minutes left. Is anyone with something to share on this one? Or you let me just show it quickly because we don't have enough time, because I have one thing left to show you the entire program that we have. So in this one, first step, what you do is you got the dy, put the y's on one side. You have here y squared minus 1. It's a numerator, so it goes down here as denominator, y squared minus 1. You have a dx here, it's a denominator, so it goes up as numerator. So it becomes dx over x squared minus 1. And you always make sure that you have your dx and dy's as numerator. You never put them as denominators when you're solving. Put them on top. And so here we need to integrate this. How do we integrate this? You have a choice. You can go by looking at table integrals to write this down, but you can also do partial fractions to answer the question. And in doing partial fractions, I can tell you that here, this is 1 over y minus 1 minus 1 over y plus 1 dy 1/2. So that you do partial fractions on this. Why is that true? Because when I want to do partial fractions, I write down, let me put this here. I write down that 1 over y squared minus 1 is a over y minus 1 plus b over y plus 1, right? I solve this. You remember this? You solve this by finding common denominator, identify and solve for a and b. This is how you get this. But usually when it's this simple, what I do is I just take the two factors I write down as denominators, y minus 1 and y plus 1. And because y and the y are here, I just put a minus so that if I'm putting them up there, the y's will cancel. And then I see how much the top is going to be. It's going to be 1 minus minus 1, 1 plus 1, 2. So because it's 2, I divide by 2. That's how I do. Does that make sense?
Yes.
So whenever it's just two terms, it's always easily done that way. Put the denominators here, put a minus between so that the y's cancel, and then you figure out what is the top, and then you take 1 over it. And then the right-hand side is the same thing, right? Because it's x squared minus 1, that's y squared minus 1. So we can write this also as 1 over x minus 1 here, and x plus 1 dx. Now the 1/2 we can cancel, and now we write down this is integral of 1 over y minus 1 minus 1 over y plus 1 dy equals integral of 1 over x minus 1 minus 1 over x plus 1 dx. And then you integrate both sides. Now this gives you ln absolute value of y minus 1 minus ln absolute value of y plus 1 equals ln absolute value of x minus 1 minus ln absolute value of x plus 1. And usually when everything is in ln like this, you put the constant of integration as natural log of the constant, so that when you remove the natural logs, everything just cancels. So when I do this, I exponentiate both sides. When you exponentiate both sides of the equation, you get e to natural log of y minus 1, that's y minus 1, times e to negative, that becomes over y plus 1, because e to negative natural log of absolute value of y plus 1 is 1 over y plus 1. Okay, e to negative natural log is 1 over the number that you have inside the natural log. So that's why this comes down here. And on the right, it's the same pattern that you have. So that's x minus 1 over y over x plus 1. And then times ln of c, e to the ln of c is c. So times c. And that's how you solve the equation in this case. And now you can stop here, or you can continue. And it says y of 2 equals 2. So y of 2 equals 2. So you can put that in here. That'd be 2 minus 1 over 2 plus 1 equals 2 minus 1 over 2 plus 1 times c. So you get c equals 1. Therefore, your answer is y minus 1 over y plus 1 equals x minus 1 over x plus 1. My best guess that is that you do this, you're gonna end up with x. If you solve this for x, y, you're gonna see that x is equal to y. So this solves as y equals x. Just by cross multiplying, things cancel. So you cross multiply this, you get y minus 1 times x plus 1 equals y plus 1 times x minus 1, right? Cross multiply, open the parentheses. xy, they cancel. Minus x stays in this, you get what? Give me a second. You get x, y minus x plus y minus 1 equals x, y. Plus x minus y minus 1, right? So this is what you get when you cross multiply. Minus 1 cancels, xy cancels. You get 2x equal 2y. So you get 2x, 2y, so x equal y. So I guess the right thing, right? So the only solution of that problem is the equation y equals x, straight line. Now, what else I wanted to show you was this, which is nothing but our complete program for the whole semester. So if I put this on this first video of the first class, you can always see it, right? So this is the program starting today, January 19, all the way down to your final exam. So every day the topic is listed. Next time it's homogeneous equations, and then exact equation, then linear first order, review session, test 1, return Bernoulli equations, and so on. That's the thing. So I will take a picture of this also somehow that it posts on Blackboard. And I hope if it's in a video like this at the end, sometimes if somebody watches, you will see that. Any questions? I think we are at the end of the class time, right? So you have any questions, feel free to ask. If not, then this is it.
Thank you.
All right.
Thank you very much.
Thank you for listening.
Yeah.
See you next time.
Thank you. Have a great day.
Same to you. I'm just making sure I have all of this on the screen so that it remains on the video.
Hey, Dr. Longlaw.
Yes, sir.
Is there any possible way that I could reschedule test 4 or like the day, like for the review session? Could I like reschedule it to Tuesday? I know it's a long ways away, but
you have something, you have a university thing there or what?
No, sir. I'll be going with my family to Florida.
Okay, I don't know, but usually it's gonna be a bit hard to go away, but it can be, let's say, maybe the day before that or after that, but it can be all the way down to Tuesday.
Okay, I mean, I can do that, like whichever works best for you. I was just wanting to let you know.
Yeah, it's good to.
I don't want to wait like the week before and be like, hey, like I'm not gonna be able to do the test.
Yeah, it's good to say it ahead of time so we can see. But I'm just telling you that if it's possible, it's always maximum 1 day around that day that is given, right? Because I don't want to be changing things because,
Right.
yeah.
Yeah,
Either.
that one's that could work. But I mean, we could talk about it when it comes a little closer to it. But I just want to bring that up and see how that goes with that.